Hi everyone, I'm Vinit Patel from UOW. In the next 5 minutes, I'll share a simple idea. If our trains can feel the track while carrying passengers, we can fix problems earlier, safer, and cheaper. I'll show you the problem, the old playbook, my research question, what the evidence says, and a practical pilot plan. Moving on to the next slide. The 2 minute commute problem. Every morning, Sydney's rail moves thousands of people smoothly until a tiny defect becomes a big delay. The hidden hero here is the track. When it degrades, you feel it as a wobble, then a slowdown, then a timetable ripple. Two constraints make this hard. First is false height between inspections. Second, our night work windows are tiny and shared with other projects. So the question for me became, how do we spot issues earlier and choose the smartest fix so trains stay safe, fast, reliable, and affordable? That's the journey we'll take, starting with why the old playbook struggles. Comparing to the next slide, why the old playbook struggles. Traditionally, it's inspect, wait, and big fix. We do periodic checks if we miss the early warning. The first sign is a speed restriction or a surprise defect. And then we need a larger possession to fix it. Costly for crews, passengers, and the timetable. The proactive alternative is sends continuously small, timely fixes, which suggest us if trains themselves act as sensors, we can catch roughness as it begins, plan short, targeted interventions, and avoid the big disruptive jobs. Think dentist. If you wait, it's a root canal. If you check routinely and act early, it's a quick clean. The same logic applies to the track as well. Moving on to the next slide, what's my research question was. So in this slide, as you can see, my research question, how can Sydney trains combine in-service condition monitoring with life cycle cost optimized grinding renewal while respecting corridor protection rules to maximize safety, resilience, and minimize total cost? These are the three pillars: sense, decide, and do. Sense is to use everyday trains to detect fatigue continuously. Decide chooses actions using whole of the life cost, not just this week's budget. And do execute with the strict safety and corridor protection limits for noise, vibration, induced movements, and access. Moving on to the next slide, what does the evidence says? Train sensors work. Cars feel cars body, bogie accelerators feel roughness and reveal trends earlier than monthly runs. We can pinpoint faults. GPS and yaw rate mapping ties as a bump to the exact chain age. Grind smart and save big. Well timed grinding, often paired with harder rail on tight curves, can halve long run cost while lifting reliability. And greener layers up, that's rubber enhanced ballast layer damp vibration and slow ballast breakage, useful on busy commuter lines. Bottom line, the tech is ready and the value is real. Moving on to the next slide, my design, which is a simple four-step loop. Sense, score, select, and schedule. Sense is to tap in service acceleration streams for regular trains, auto flag anomalies against the baseline. Score is to convert signals into green, amber, red health grades with risk context curvature, speed, tonnage, and history. Select is a run, a life cycle value test, grind now or later, spot renew, minor temp, pick the best safety per dollar option. And schedule is for to fit the work inside night access corridor protection rules, bundle tasks to shorten possessions and avoid revisits. This loop repeats, data improves thresholds improve decisions improve service. Moving on to the next slide, why this beats business as usual. Earlier fixes, predictable workbanks, and shorter, safer positions, that are the upsides, lower whole of the life cost, and easy to explain by this job story for funders. And the watchouts are data quality, as you can see, change management for crews, and competing project squeeze access. Moving on to the next slide. What will be the payoff for this? So, three outcomes: safer rides, then fewer delays, and better value. Here is a 90-day pilot plan to validate my statement. Pick a segment, mount sensors, stand up a dashboard showing green, amber, red health and trend spark lines, run LCC choices on top 5 hotspots, book positions inside corridor tasks, and also measure slow order minutes avoided, defect, backlog, change, crew feedback. If results are positive, scale to the next corridor and tighten the thresholds. That's how we get safer rides, fewer delay, and better value without waiting for a crisis. So, thanks for listening, and that's all my references, which from my work, from my report, which I have already submitted. Thank you so much.